This screencast demonstrates the use of reactor models R-Stoich, R-Gibbs, R-Plug, and R-CSTR through an example problem on the production of ethyl acetate. Open your Aspen simulation and begin a new flowsheet using metric units. To start, enter the components ethanol, acetic acid, ethyl acetate, and water. Choose NRTL Hawk as your method. Watch the related video to learn more about choosing a property method. When all the information is entered, run the property analysis and then go to the simulation environment. To run all 4 reactors in one simulation, create a duplicator block, which duplicates an inlet stream and can send it to multiple locations. Create an R-Stoich, R-Gibbs, R-Plug, and R-CSTR reactor, renaming each as such. Add a feed stream to the duplicator and connect the duplicator outlets to each reactor, naming the streams F reactor type. Create product streams from each reactor, naming them P reactor type. Click the blue next arrow to specify the feed conditions. The stream enters at 70 degrees Celsius in 1 atmosphere. Input the following values in kilomoles per hour: 8.892 water, 186.59 ethanol, and 192.6 acetic acid. Click the blue next arrow to go to the CSTR block. For the sake of comparison, all reactors will be specified at 1 atmosphere and 70 degrees Celsius. Make sure all reactors have vapor liquid selected as the valid phases. For the CSTR, specify a volume of 0.14 cubic meters. You can see that the R-CSTR model requires a reaction to be entered before you can proceed in the simulation. Scroll down on the menu tree and click on the Reactions folder. Click New, keep the label as R1, and select a power law reaction type. Click New again and enter the forward reaction. Ethanol plus acetic acid goes to ethyl acetate and water. Assume the reaction is first order with respect to each of the reactants and zeroth order with respect to the products. Enter -1 and 1 for the coefficients and 1 and 0 for the exponents of your reactants and products respectively. Now enter the reversible reaction. Ethyl acetate plus water goes to ethanol and acetic acid. Enter -1 and 1 for the coefficients and 1 and 0 for the exponents of your reactants and products respectively. Press the blue next arrow to input the reaction's kinetic information. For both reactions, the reacting phase will be liquid and the concentration basis will be molarity. For the forward reaction, specify a K value as 1.9 times 10 to the 8th and an E value as 5.95 times 10 to the 7th joules per kilomole. Make sure the units are correct before proceeding. Repeat the process for the reverse reaction by selecting it from the drop-down menu. The K value for the reverse reaction is 5 times 10 to the 7th and the E value is 5.95 times 10 to the 7th joules per kilomole. Press the blue arrow to go back to the CSTR reaction tab. You can now move the R1 reaction to your selected reaction set. Pressing the blue arrow brings you to R-Gibbs. Remember the reactor is operating at 1 atm and 70 degrees Celsius. Pressing the blue next arrow allows you to specify the reactor type. Choose reactor with specified temperature as the reactor type and choose the operating condition as constant at specified reactor temperature. Enter 70 degrees Celsius. Pressing the blue arrow brings you to the Configurations tab. Input a length of 2 meters and a diameter of 0.3 meters. Ensure the process stream valid phases are vapor liquid. Go to the Reactions tab and select R1 as your reaction set. Pressing the blue arrow again brings you to R-Stoich. Input your reactor temperature and pressure. On the Reactions tab, click New and input the forward reaction with the appropriate coefficients. Enter 0.7 as the fractional conversion of ethanol. Press the blue arrow and run the simulation. Open the stream summary and view the results. You can compare the production rate of ethyl acetate of the 4 reactors. You can see the R-Gibbs actually produces the most ethyl acetate while R-CSTR produces the least. Additionally, if you click on the CSTR block results on the menu tree, you can see the heat duty required for this equipment. Watch the following video in the YouTube playlist to see an application of the Reactors chapter on a chlorobenzene production plant. For more Aspen tutorials, visit the Lafayette CHBE YouTube channel.